Hey kiddos, Happy New Year. We're going to start Unit 8. I know we're skipping 7, but that's the order I like to do it in, and so that's what we're doing. So this is the beginning of Unit 8, and it's all about motion. So you can see that there's a lot of vocabulary here. We're not doing all of this in one day. This is going to be over the course of a week at least to get through everything. So this is inside your content library in OneNote. You can go print it if you want to, or just drag it into your notebook. But let's focus today on your vocabulary. We're not even going to look at this column today. We're not doing vectors today. That's going to be tomorrow or the next day. And we're really not even going to get down into some of these at the bottom. But here's the big piece that you got to know. You've got to know how to move between position, velocity, and acceleration. So my physicists should probably be okay with this. To move from position to velocity, you take a derivative, is what that's saying to you. And then to acceleration would be another derivative. So if you were given position in the question and they were asking for acceleration, you'd have to take a second derivative. Take your brains back to like October when we had F and they were asking questions about F double prime and we had to move through all of these derivatives to get there. That's what we're doing. It's just now these functions have names, so we're not going to call them F and F prime. We're going to call them position, usually X for position, and then V for velocity and A for acceleration. And then the same thing to move backwards, you have to take integrals. So I hope you remember how to do some calculus. The integrals and derivatives you're taking today are not going to be terrible. You should not have any by parts to do. Don't worry about that. And then all of your questions are going to have one of these terms in them, and you can go look and see what the calculus is and apply it to your question. So, just looking at one of them real quick, if the question wants to know when this particle is at rest, I would go here to at rest, and the analysis I would need to do is I'd need to find where velocity is 0. So it may be a situation where they have given me position in the question, and then they want to know when it's at rest. The first thing I'd have to do is take that derivative. I'd have to take dx dt to find velocity, and then set it equal to 0 and solve. So there can be calculus and then algebra. There could be algebra and then calculus. There could be just algebra. It's all vocabulary. If you know your vocabulary, you're just playing the game. All right, so let's look at some questions. The first we're going to do are all graphical. So notice that this is a graph of velocity, and I could ask a billion questions about this thing. Like I could ask, when is this particle at rest? And then I would go back to my vocab sheet. Oh, at rest is when velocity equals 0. So the velocity, which this is a graph of, equals 0 here at 1, here at 4, here at 9, here at 13. So I would say I missed one. T equals 1, 4, 9, 13, 17 are all of the places that this particle is at rest. I could ask you, when is this particle moving to the right? And I would go back to my vocab sheet and I would say, oh, look, moving right. Notice it says right or up. This up and this down are going to apply over here when we get to vector stuff. So that's probably not going to come up today. So right and left are here. We're moving right. So I need to know when velocity is positive. Not increasing, but positive. Remember that there's a distinction there. So if this, again, is my velocity graph, this is where velocity is positive because it's above the axis. So I would say it's moving right between 1 and 4, again from 9 to 13, and again from 17 to 18. And it stops at 18, so I'm not going to infinity, etc., etc., etc. So they could even ask you, they could give you this thing, and they could ask you, when is the acceleration negative? Okay, so if I go to my vocab sheet, I don't have acceleration negative on my vocab sheet. But if I know this, I don't need it. So I know acceleration is the derivative of velocity. So they're asking me, When is the derivative of this graph? Instead of writing acceleration, I'm going to relate it to what I'm looking at. When is v prime? Negative. So go back to, was it November? I don't know. It feels like forever ago, and it also feels like yesterday. But go back to when we were doing all that graphical analysis of f, f prime, and f double prime. This is the same thing. So v prime is going to be negative when the slopes of v are negative. Remember, this is v, so slopes would be negative anywhere that it is decreasing. So it's going to decrease. Let me get a highlighter. It's going down here, and it's going down here, and that's it. So I would say it's decreasing between 3 and 7, and then again from 11 to 14. And on and on and on. So they can give you this graph and ask you a billion questions, and they'll change the graph up on you and ask you a billion questions. Okay, so if you want to pause and go to Delta and work those 3 graphical motion questions, this would be a really good place to do that, because I'm going to move away from graphical now. So here's your next question. We're going to do 3, by the way. That was 1. Here's 2. This time, I don't have a graph, but they're asking the same stuff. So we have a particle moves along the x-axis so that any time greater than 0, velocity is given by. Okay, time out for 1 second. Let's talk about this moving along the x-axis business. That just means that we're only moving in 1 dimension, which means, again, that we're not in this vector calculus place, because vector calculus is when you're moving in 2 dimensions. You're moving left, right, and up, down at the same time. So that's a different day. So don't be upset when you see those words, because every single one of your questions will say that. All right, determine if the particle is speeding up or slowing down. So speed up, slow down. So before I go back to your sheet, speeding up and slowing down are not acceleration. That is not the same thing as acceleration. Back in your vocab sheet, looky here, speed up and slow down. So here's what it means. In order to be speeding up, velocity and acceleration have to have the same sign. I mean that they're either both positive or they're both negative. To slow down means they're working against each other, and you have a positive velocity but a negative acceleration, or a negative velocity and a positive acceleration. So they're either working together or they're working against each other. Working together speeds up, working against each other slows down. So I have to go find those 2 values and see if they're both positive, both negative, or one of each. So they gave me velocity and they're asking about time 1. So let's go find the velocity at time 1. That's going to be 2 times 1 plus 11, which is 13. That's greater than 0. The other one I need is acceleration. Ooh, acceleration. Acceleration is the derivative of velocity, so I'm going to take the derivative of this function. I told you they would be friendly today. It's 2. That's also greater than 0, so we can say that this one is speeding up because both of 1 and v of 1 are positive. Doesn't matter that they're both positive, it matters that they have the same sign. Okay, last question. Particle moves along the x-axis. I told you it would again. They gave me velocity. They like to do velocity questions. If the particle, this one has a lot of information, is at position x equals 10 at time a half, what is the position of the particle at time 0? All right, so this time, I'm not going to go back to my sheet because I'm tired of clicking back and forth. This time they're giving me velocity and they're asking about position. So instead of taking a derivative, I have to take an integral. So we're going to go integrate. I'm going to pull out the constant, cosine pi t. Notice I'm not putting bounds on it. We can in a second, but I'm not going to right now. I am uncomfortable with you not having taken an integral in the last 3 weeks. So let's do this very slowly with like a u sub and ease you back into it. U is pi t. makes du pi dt. So then I have to divide out a pi. So I have 6 pi over pi. And now I have the integral of the cosine of u du. Pi's cancel. And I have 6. The derivative of sine is cosine, so the integral of cosine is sine of u. And I'm going to put the t's back in. So this is 6 sine pi t. Maybe some of you have brain power that you don't need to do all that with a u sub. Congratulations. Other thing I need here is a big old plus c. If you remember nothing from before break, please remember to put a plus c on your integrals. All right, so this is our position function. I'm going to call it x because they called it x. So my position function, x of t, is 6 sine pi t plus c. They want to know what is the position of the particle at time 0. So I could happily just chug along and put a 0 in for t, but I have this unknown here that I have to go find first. And I'm going to find it with this. It's called an initial value. I'm going to go find it using this initial value. So if I know that the position is 10, so equals 10, at time a half, I'm going to go put, oops, I lost my 6. 6 sine of pi times a half would be pi over 2 plus c. I know my unit circle. I hope you do too. Cosine sine at pi over 2 is 1. So this is 10 equals 6 plus c. So c is 4, which means our position function is 6 sine pi t plus 4. And now I can answer the question real quick. They want it at 0. So x of 0 is 6 sine pi times 0 plus 4. Sine of 0 is 0. So x of 0 is 4. And that's it, kiddos. Lots of review on basic derivatives and integrals today. I should have told you, sorry. If you want to go keep this up in front of you and go do the second part of your delta, that's where these are coming from. Third part of your delta are from these. So good luck. Let me know if you need anything.